Welcome, class, to the Intro to Java Programming. Today will be the first lesson in a series covering several popular data types. The lesson today will introduce the concept of data type, primitive, and non-primitive. The information given in today's lesson is by no means complete, but will give you a foundation to work from and provide some good working examples. It is up to you to continue to research uses and features of existing data types, along with discovering new data types. A data type is needed for each method, property, and variable. Data type specifies the type of value and memory restrictions. The two data types are primitive and non-primitive. What does that mean? Review this slide and do some additional research if necessary. Memory can be broken down into bits and bytes. A byte data type uses 1 byte of memory to hold the value. That is 8 bits, and the leftmost bit is a flag to indicate a positive or negative number. With the remaining 7 bits, the range of values is a whole number from negative 128 to positive 127. Each data type prevents you from storing a value beyond the allowed range used in memory. If you need to hold a larger value, you need to use a different data type. Here's a list of primitive data types and the memory used. Primitive data types do not have any additional methods available. Java is a strongly typed language, which means each variable declared must be predefined with a specific data type. Once defined, it cannot be changed to another data type. Here's a quick code example that should help you understand. Let's go to our Basics project in IntelliJ and close any open tabs. Let's create a new test package called Data Types. Let's create a new class called Primitive Tests. Create a new test called TestToString. Let's import the JUnit class. Let's declare a primitive and non-primitive variable. First observation you can make is a primitive data type begins with a lowercase letter. Non-primitive data types begin with an uppercase letter. Non-primitive data types can have additional method operations like toString. Let's test the toString method on the string variable. If we run the test, it'll pass. If we try to test the toString method on an int variable type, we get a compiler error. IntelliSense on non-primitive data types offers several options. ToString is on that list. Primitive data types do not offer a lot of IntelliSense options. ToString is not on that list. We still have a compiler error. Let's comment this out. Let's create a non-primitive integer variable and test the toString. Again, notice the data type integer starts with an uppercase letter, a sign it's a non-primitive. Also notice the toString method is available. If we test this, it'll pass. Non-primitive data types are called reference types because they refer to objects, typically created by you or other developers. Correct, the classes you create are non-primitive types. There are other non-primitive types available like the string class. One last noteworthy difference between primitive and non-primitive data types are: primitive types always have a value and cannot be null. Non-primitive types can be null. We cannot easily prove this in a test without adjusting the IDE, so just remember that fact. Should you use int or integer? The answer is you should prefer int over integer unless you have a specific need. Int performs a little faster than integer. An integer is a wrapper class for int, meaning an integer class can do everything an int can do, but an int cannot do everything an integer can do. Another example could be a goalie in soccer can be a player, but a player cannot be a goalie. A goalie is allowed to do anything on the field. A player is not allowed to do the same things as a goalie. A goalie can be a player, but a player cannot be a goalie, just like an integer can be an int, but an int cannot be an integer. Let's look at some other data type examples that may build a good foundation. Here is a toy with several different shapes. The circle shape must be placed in the circle opening. Same for the square and triangle shapes. The square shape will not fit into the circle opening. The variables you use will have a specific data type based on your specific needs. Consider the toy shapes as the variable data type you might use in a program. A square is like a string data type that holds a person's name. A circle is like an int data type that holds the age of the person. A triangle is like a date data type that holds the person's date of birth. A circle shape cannot fit into a square opening. An int value cannot directly be stored in a string data type. It is an incompatible type. However, unlike toy shapes, a variable could be converted from one data type to another. The int value can be converted to a string value and then stored in a string data type. There are some obvious problems like converting ABC3 to an int. The string must only contain numbers like 3 to convert to an int. Feel free to uncomment lines 36 and 37 and see the Java error that you get. Converting an int to a string is much easier. Let's run these tests and they should pass. Do unit tests have value? Should we stop writing unit tests? Interesting. This leads us to a Coach Joe rule and an important topic, test-driven development, or TDD. Unit tests are a good way to prove our code works. A series of unit tests will prove that a change in one area does not break logic in another area. We have been writing unit tests to prove that a concept works, instead of testing actual code. This is an excellent way to learn new topics and experiment with ideas in a way that can be written and prove it works. Later, when you want to review a specific topic, you have a working unit test that can be run and inspected. Once we cover the other data types, you'll have a chance to practice TDD while writing a coding project. Junior level developers typically fail to consider the importance of unit tests and spend much of their time writing and debugging production code. Senior level developers know the importance of unit tests and will typically write more lines of unit test code than production code. On that note, a big warning flag should be raised if you're working at a company for a manager that fails to see the importance of unit testing. I'd be willing to bet that that's just one of many poor decisions they will make. Keep your resume and exit strategy up to date when things go bad. Guess who gets blamed? When it comes to writing unit tests or not, I'll leave that decision for you to consider. Ernest Hemingway once said, "The first draft of anything is rubbish. The code you write will be no exception. The purpose of the unit test is to test a piece of logic. It is likely the first draft of your code may work, but will need to be cleaned up. The unit tests should pass on your first draft and after each additional change." This is why I always say, make it work, prove it works, and then make it better. You should now have a basic understanding of data types and know the difference between primitives and non-primitives. You were also introduced to the concept of test-driven development and should have a better understanding on the purpose of unit tests. Your optional homework assignment is to determine the number of possible values for a 1 byte, 2 byte, 4 byte, and 8 byte data type. In the next lesson, we'll discuss the data type for strings. Remember, future senior developers, make it work, prove it works, then make it better. Ready? Break!